All right, so what I'll do here is just cover the remaining 10 problems here on this review sheet. And it does say here, find the intervals on which f of x is increasing, the intervals on which f of x is decreasing, and the local extrema. All right, so in this problem, we got f of x is equal to negative 4x squared minus 32x minus 21. Okay. So the first thing I need to do here is find out what the derivative of this function will be to find out my intervals in which it's increasing or decreasing. So this is what, negative 8x minus 32. So that's what f prime of x will be. Okay? Now to find my possible critical points, I set the function f prime of x to be equal to 0. So that means I have negative 8x minus 32 is equal to 0. And then to get negative 8x by itself, we'll add 32 to both sides. So that means negative 8x is equal to 32. Divide both sides by negative 8, you'll get x is equal to negative 4. So that's my possible critical point. All right, so now we're going to find the intervals in which it is increasing and or decreasing. So I have to draw a number line, put this on the number line, and negative 4 will be on that number line. And that's going to separate this number line into two different intervals. One will be from negative infinity up to negative 4. Notice I'm using parentheses. And then the other one will be from 4 to infinity. Now I'm going to pick a test point and substitute that value into the f prime of x function to see if it's positive or negative. If it's positive, it's increasing, or if it's negative, it's decreasing. So if I pick, let's say, test x equal, let's try 0. I'm sorry. This should be negative 4. This should be negative 4. So instead of 0, on this side, we're going to use negative 5. And on the other one, for negative 4, 0, we'll test x equals 0. But for negative 5 here, f prime of negative 5 would be, let's say, negative 8 times negative 5 minus 32. Well, negative 8 times negative 5, that's 40. 40 minus 32 is 8. And it is positive here. So from negative infinity up to negative 4, the graph of that function will be increasing. Okay. And then for x equals 0, we do f prime of 0. That's going to be negative 8 times 0 minus 32. Well, negative 8 times 0, that's 0 minus 32, that's negative 32. And it is negative, so that means on the interval from negative 4 to 0, the graph will be decreasing. All right, so to pretty much answer that question, the function is increasing on negative infinity to negative 4. And decreasing on the interval from negative 4 to infinity. Now let's see if we have a local maximum or local minimum. Here it's increasing And then after negative 4, it starts to decrease. So we only have a local maximum. So we can just say here the local maximum is at x equal negative 4. And of course, there's no local minimum because all we have is just increasing, then decreasing. Okay. Are there any questions about problem number 21? Now, I realize that in the on this review sheet, they do ask for that x value, but they also ask for the y value. On the exam, I would just want you to just give me the x value. Yeah. Okay. If, for the y value for that, you just substitute your x with negative 4, and then you'll end up getting positive 43. I've already worked it out. All right, any other questions? Number 22 is finding the indicated derivative for the function f of x equals to 3x to the fourth minus 5x squared plus 7x minus 5. And we're looking for f double prime of x. So here we got f of x is equal to 3x to the fourth minus 5x squared plus 7x minus 5. So to find the second derivative, you must find the first derivative. Okay? So for that first derivative, f prime of x, that would be what?
12x cubed minus 10x plus 7?
Yeah. 12x cubed plus 10x plus 7. That's your first derivative. Now we're going to use that to help us find f double prime of x. That's the second derivative. So the second derivative here would be, what would be your second derivative?
Will it be, how's it plus 10x?
Oh, minus 10x. No wonder. See? Okay. So f prime of x is 12x cubed minus 10x plus 7. All right, so the second derivative would be, well, bring down this 3, multiply by 12, you're going to get
36x squared.
36x squared minus 10. Okay. Any questions about finding the second derivative of a function? Okay. All right, now number 23. Number 23 looks like this. Find the intervals on which the graph of f is concave upward, the intervals on which the graph is concave downward, and the inflection points. And we have f of x equaling to negative x to the fourth plus 24x cubed minus 24x plus 19. All right, so start with a brand new page. So here you've got f of x equals negative x to the fourth plus 24x cubed minus 24x plus 19. And with that, we do need to find not only the first derivative, we also need to find the second derivative when we're dealing with the concavity. So let's first find that first derivative. So for this function, what would be its first derivative?
Negative 4x cubed plus 2x squared
Mm-hmm.
minus 24.
Minus 24. Okay, so we got f prime of x equaling to negative 4x cubed plus 7x squared minus 24. Now f double prime of x, the second derivative, would be,
Negative 12x squared plus 72.
well, this is the derivative of 72x squared.
Oh, yeah, yeah, yeah. I didn't have the square on mine.
Okay,
So, yeah, that'd be 144.
right, x. Okay, when you bring the 3 down, multiply by negative 4, that's negative 12. Copy the x over to the 1 less power. Plus, bring this 2 down, multiply by 72, you get 144, x. So that's the second derivative. Now, when you're finding your inflection points or your possible inflection points, you'll take f double prime of x, set it equal to 0. So that means I'm having negative 12x squared plus 144x equal to 0. And let's do this here. Let's factor something out in negative 12x squared and 144x. What can we factor out?
Negative 12.
Yeah, negative 12. What else?
X.
And x. All right. So if I factor out negative 12x, that would be a positive x. And then positive divided by negative will be a minus. 144 divided by 12, that will be 12. So I have negative 12x times the quantity x minus 12 equal to 0. And then we set each factor equal to 0. So that means negative 12x will be equal to 0. X minus 12 will be equal to 0. And then we solve each equation for x here. So for negative 12x equal to 0, that means that x will have to be equal to 0. And then for the x minus 12 equals to 0, x will have to be equal to 12. These are my two possible points of inflection, 0 and 12. So now this is where we put those two numbers on a number line to see whether the graph will be concave upward or concave downward. Let's see, I'm going to put 0 here. And I'm also going to put 12 over here. So for here, we got 3 different intervals here, from negative infinity up to 0. And then the next one is going to be from 0 to 12. And then the other one will be from 12 to infinity. And on each interval, I will pick a test value to determine whether it's positive or negative. If it's positive, the graph will be concave upward. Or if it's negative, it's going to be concave downward on that interval. So for negative infinity to 0, I'm going to try negative 1 for x. And I'm going to substitute the negative 1 in for the x in this f double prime of x function. So this is f double prime of negative 1. That'd be negative 12 times negative 1 squared plus 144 times negative 1. Well, negative 1 squared would be 1 times negative 12 would be negative 12. 144 times a negative 1 would be minus 144. This will end up being negative 136, but it's negative. So that means from negative infinity to 0, the graph of this function will be, well, not decreasing, concave down, because it's negative. Here we're just dealing with concavity here, since we're dealing with looking for the second derivative. So for concavity, you have to do second derivative. Now for 0 to 12, I pick x equal 1. And then use that second derivative and replace the x with 1. So this will be negative 12 times 1 squared plus 144 times 1. Let's see, 1 squared would be 1 times negative 12, that's negative 12, plus 144 times 1 is 144. This will end up being, I think, 132, which is positive. So that means that the graph of this function on the interval from 0 to 12 will be concave up. And then for 12 to infinity, I'm going to use 13. I know that's a big number that we'll be using here, but let's see what we can do with that. This is f double prime of 13. That's equal to negative 12 times 13 squared plus 144 times 13. And I'm going to use my calculator to calculate this right here. Clear this out. Let's see, negative 12 times 13, and that's going to be squared, plus 144 times 13. And here I get negative 156, which is, of course, negative. So that means that the graph of this function will be concave down. Now, our inflection points occur when, in this case, we change concavity, when there's a change in concavity. Here we're going from concave down to concave up. So that means at 0, that's an inflection point. And also, we have another inflection point, and that's 12. It's concave, its concavity changes from concave up to concave down. All right, so let me go ahead and answer what they're asking for. The intervals on which x is the graph of f concave upward. It's only concave up on this interval from 0 to 12. It's concave down on two different intervals, negative infinity to 0 and from 12 to infinity. So there are two intervals where it's concave down, negative infinity to 0 and from 12 to 0, 12 to infinity. Now let's determine the x-coordinates of any inflection points here. Inflection points occur at x equals 0 and at x equals 12, because at 0 we have a change in concavity, and at 12 we also have a change in concavity. Okay, and I think that's all that they asked for in problem number 23. Any questions on this? All right, number 24. Here they want the absolute maximum and minimum if either exists for f of x equals x squared minus 10x plus 2. So here we got f of x is equal to x squared minus 10x plus 2. All right, so let's go ahead and find the first derivative of this function. So what is f prime of x going to be?
2x minus 10.
2x minus 10. Okay, and then we'll take this f prime of x, set that equal to 0. So here we got 2x minus 10 is equal to 0. And if I add 10 to both sides, you'll get 2x is equal to 10. And divide by 2. X will have to be equal to 5. Okay. Now, in this case here, we can find the second derivative of that function. Well, if f prime of x is 2x minus 10, what must f double prime of x be? Just 2. And then what I'm going to do is take this x equals 5 and substitute it into the double prime of x function. Well, that's easy. That's going to equal to 2. And if it's positive, that means we have a local minimum. And here we're using a second derivative test. Okay. So that's where the local minimum occurs. Well, actually, it occurs at x equals 5. But if they want the coordinate for that, we can say here, just substitute 5 into the original function. I mean, 5 squared would be 25 minus 10 times 5 would be 50 plus 2. 25 minus 50, that's negative 25. Negative 25 plus 2 would be negative 23. So that would be your absolute maximum. So our absolute maximum is negative 23 at x equals 5. Excuse me. So that's how we work problem number 24. Any questions? All right, number 25. Find two numbers whose sum is 18 and whose product is a maximum. Two numbers whose sum is 18 and the product is a maximum. Okay, so in this case here, x will be the first number, and the y will be the second number. All right, now we're told that the sum is 18, so that means x plus y will be equal to 18. And the product will be a maximum, so that means I'm going to do this. P of x is equal to x times y. Okay, because product means you're going to multiply. And I'm going to put P of x in terms of x. So that means I need to solve this equation for y. And then do the substitution. So to do that, I need to subtract x on both sides. That will tell me that y is equal to 18 minus x. So for that 18 minus x, I'll go ahead and substitute it for this y in my P of x function. So this will be P of x is equal to x times the quantity, 18 minus 8. Now, if I distribute the x over the 18 minus x, this will be 18x minus x squared. And then what I'm going to do is take the derivative of this right here. So p prime of x is this. The derivative of 18x will be 18 minus 2x. And then I'm going to substitute, well, replace the p of x with 0, set this equal to 0. So it'll be 18 minus 2x is equal to 0. And let's see here, if I subtract 18, this will be negative 18 equals to negative 2x, so that means x will have to be equal to what?
Positive 9.
Positive 9. Okay? And we're looking for a maximum, so that means 9 will have to be the maximum here. Well, if x is 9, and I know what y is, 18 minus x, I just simply replace the x with the 9, so be 18 minus 9, which is 9. So that means x is equal to 9, and y will have to be equal to 9. So those would be the two numbers whose sum is 18, and the product will give me a maximum. All right. Questions on number 25? All right, now problem number 26 through 30 deals with integrals. So that's all of chapter 5 there. Okay, so let me do this. And in number 26, we're going to do the integral of x to the 7th e to the x minus 2 x to the 6th, all divided by x to the 7th dx. Okay. So now, what I'm going to do here is divide each of these terms in the numerator by that monomial x to the 7th. So I'm going to write this as x to the 7th e to the x divided by x to the 7th minus 2x to the 6th divided by x to the 7th dx. You're going to see here that the x to the 7th divide out. All I'll be left with is e to the x, and then minus. I'll have the 2 in the numerator, but if I do x to the 6th, all of that's gone, but 6 of these x to the 7s will be gone, and I'll be left with an x in the denominator. So I have e to the x minus 2 over x, and that integral will be dx. Okay, let's integrate each part by writing this as the integral of e to the x dx minus, and I'll pull the 2 out in front, so it'll be 2 times the integral of 1 over x dx. Now, what's the integral of e to the x? Just e to the x minus 2 times the integral of 1 over x dx would be natural log. So it'll be 2 times ln of the absolute value of x, and since it's an indefinite integral, we must include the plus c. Okay. So that right there is just problem number 26. Okay. Any questions about that? All right, number 27 is the integral of x plus 5 divided by x squared plus 10x plus 49 dx. Now this one we're going to have to integrate by using substitution. Okay. So that means here we're going to have to let u equal to something, preferably the expression in the denominator. So here I'm going to let u equal to x squared plus 10x plus 49. That would mean du will have to be, what? 2x plus 10 dx. And in this case, you have to include the dx as well. All right, in this case here, what can we factor out in 2x plus 10? A 2. So if I factor out the 2, 2x divided by 2 would be x, plus 10 divided by 2 would be 5 dx. Notice in the numerator, I get x plus 5 dx. So if I want this to be x plus 5 dx, I need to divide both sides by 2. So you're going to see I'm going to have 1/2 du equaling to x plus 5. I'm going to put this in parentheses, dx. So now we can do the substitution here. This denominator, x squared plus 10x plus 49, that would be u. This x plus 5 dx, that's going to be 1/2 du. So now we're going to have the integral of, the numerator will be 1/2 du divided by u. But I can pull the 1/2 in front, so it'll be 1/2 times the integral of du over u. And what would be the integral of du over u? Anyone? Would that be the natural log of the absolute value of u, and then plus c? And then we do the back substitution. That u was at x squared plus 10x plus 49. But I'm going to do this without the absolute value symbol, because by looking at this problem, this will never be negative. So it'll end up being 1/2 the natural logarithm of x squared plus 10x plus 49 plus c. Okay. Any questions about problem number 27? All right, number 28 is another integration by substitution. And in number 28, I have the integral of s to the 5th times the quantity 3 plus s to the 6th. That quantity will be squared ds. All right, so now let's do some substitution here. Let's find out what we can assign u to be. So here I'm going to let u be what's in the parentheses. That'd be 3 plus s to the 6th. That means du will have to be 6s to the 5th dx. Or I should say ds, since our variable is s. Okay, we got s to the 5th and ds. So if I want this to be s to the 5th ds, I need to divide both sides by 6. So that means I have 1/6 du is equal to s to the 5th ds. And maybe if I wrote it like this, 3 plus s to the 6th, and that's squared. And then put the s to the 5th next to that ds, you'll see that s to the fifth ds will be 1/6 du, and this 3 plus s to the 6 will be the u. So that means here I have the integral of u, and that's going to be squared, times 1/6 du. Put the 1/6 out in front, so it'll be 1/6 times the integral of u squared du. And then we use the power rule for integration. So the integral of u squared du will be what? U to the third over 3. And again, this is an indefinite interval. You have to include the plus c. And then 1/6 times the third will be 1/18. And then I'll back substitute by replacing that u with a 3 plus s to the 6. That's going to be cubed plus c. And I would leave it like this as a final answer. All right, questions on number 28. All right, problem number 29. Is this. They want you to calculate the integral from 4 to 6 of 2x squared dx, and you're given this, the integral from 4 to 5 of x squared dx, that's equal to 61/3, and then the integral from 5 to 6 of x squared dx, equaling to 91/3, and then the integral from 4 to 5 of x dx, equaling to 9/2. Well, let's start by pulling that 2 in front of that integral sign. So the 2 goes in front of the integral from 4 to 6 of x squared dx. Now, notice in these, I don't have an integral from 4 to 6. But I do notice something here. I have an integral from 4 to 5, and I also have an integral from 5 to 6. I can use both of those to help me evaluate this. So I'm going to rewrite this as the integral from 4 to 5 of that x squared dx plus the integral from 5 to 6 of x squared dx. So here we got 2 times. Well, the integral from 4 to 5 of x squared dx is up here. That's 61/3. So I'm going to have 2 times, and in the bracket 61/3, plus the integral from 5 to 6 of x squared dx. I have that right here. That's 91/3. Well, if I add those two together, 61/3 and 91/3, that's going to be 152/3. And if I do 2/1 times 152/3, I will end up getting 304/3. Okay. Any questions on problem number 29? And finally, number 30. Here we use the fundamental theorem of calculus to evaluate this integral from 1 to 2 of 3x squared plus 5 dx. So here the integral from 1 to 2 of 3x squared plus 5 dx. Okay, let's integrate each term that we have here. And also use the constant multiple rule as well. That 3x squared, I can pull the 3 out in front. So it'd be 3 times the integral from 1 to 2 of x squared dx plus, let's pull the 5 out in front of the integral from 1 to 2 of dx. And then let's go ahead and do the integration here. The integral of x squared dx will be x cubed over 3. And then 5 times the integral of dx will be just x. So it'll be 5x. And all of this will go from 1 to 2. And here these 3's divide out. We'll be left with the integral of x cubed plus 5x. And this will go from 1 to 2. And from here we do the upper limit minus the lower limit. So here, substitute your x with the 2. It'd be 2 cubed plus 5 times x, which is 2, minus then the lower limit. 1 would be put in place of x, so it'd be 1 cubed plus 5 times 1. So here we're going to have 2, and that's cube plus 5 times 2. That's 18 for this part, minus what I get for the lower limit. That'd be 1 cube plus 5 times 1. Oops. 1 hat key cube, get out of the exponential part, then 5 times 1. Okay. Plus 5 times 1. 1, and then cube, get out of this, then plus 5 times 1. That would be 6. So if you do 18 minus 6, that would give you 12. And that 12 represents the area bounded by the graph of 3x squared plus 5 and the x-axis from 1 to 2. Are there any questions about problem number 30? Or does anybody have any questions about what will be on your final exam?